Hello and welcome to the Progressive Coder channel. In today's video, we are going to talk about Kafka Producer's message sending strategies. So we already looked into Kafka Producer basics in a previous video. So you might want to check it out in case you want to start from the very beginning. In this video, we are going to directly jump into looking into the strategies. There are three main strategies of sending messages in Kafka: fire and forget, synchronous send, and lastly, asynchronous send. We will look at each strategy one by one. Since we will be using a Java Maven project to demonstrate the strategies, we will first need to add a particular dependency to the pom.xml file. This dependency pulls in the official Kafka client package that contains all the classes we are using to create and use a Kafka producer. Let us now look at the first strategy, that is fire and forget. As the name suggests, in this strategy we send a message to the Kafka Broker and forget about it. Basically, we don't care if the message arrives successfully or not. Since Kafka is highly available, chances are that the message will arrive successfully. Also, in case of any issues, the producer will retry sending the messages automatically. So the chances of a message arriving successfully are very high. But if there is an error that cannot be retried or there is a timeout, messages will get lost. The application will not get any information or exceptions about this. This code sample shows the implementation of the fire and forget strategy. The first segment of the code deals with configuring the Kafka Producer instance. Once the instance is configured, we create a producer record object. The constructor of the producer record class takes a few input parameters: the name of the topic, the key of the message, and lastly, the actual message value. Once the producer record is set up properly, we send a message to the Kafka Broker using the producer send method. The call to this method is wrapped within a try-catch block to handle exceptions that might arise. At the very end, we flush the producer by calling the flush method. Kafka Producer does not actually send the message immediately, but places it in a batch. A separate thread ships the message after some time. However, this piece of code immediately terminates after calling the producer send, even before a separate thread can send the message. The flush method basically flushes the accumulated records in the producer with immediate effect. Let us now look at the second strategy, synchronous send. On a purely technical level, Kafka Producer is always asynchronous. However, we can force it to behave in a synchronous manner. Check out this code for the synchronous send approach. What is the difference here? Nothing much really. We have turned the send method to a synchronous operation by using producer send record.get method. Basically, the send method returns a future object. Using the get method, we wait on the future object to make sure if the call to send was successful or not. The method will throw an exception if the record is not successfully sent to Kafka. If there were no errors, we get a record metadata object that contains information such as the offset of the message. Notice that here we don't use flush. There is no need for flushing the producer. The producer will move forward only after receiving the response from Kafka. You must have already noticed the issue with this approach. With synchronous send, we are essentially making a trade-off on performance. Brokers in a typical Kafka cluster may take some time to respond to produce requests. With synchronous messages, the sending thread of our application will spend this time waiting and doing nothing else. This can dramatically reduce the performance of our application. Finally, let us look at the asynchronous send approach. This is the third approach for sending messages to Kafka and is probably the best approach for a large number of applications. Check out the code demonstrating this particular strategy. Basically here, we call the send method of the producer with a callback function. The callback function gets triggered when it receives a response from the Kafka Broker. In this demonstration, we are using a slightly different setup, a Java Spring Boot application. With Spring Boot, our application will continue running even after we send the message to Kafka. This way, we can easily configure the callback. To use callbacks, we need to declare a class that implements the callback interface provided by the Kafka client's producer package. This interface has a single function on completion. If there is an error from Kafka, the on completion will have a non-null exception. We can handle the same by printing the stack trace. In case of success, we get the record metadata that contains the topic, partition, and offset of the message. Once the class is defined, we pass an object of this class while calling the producer send method. The entire Kafka Producer configuration setup and sending the message is within the run method that comes from the command line runner interface provided by Spring Boot. The real advantage of callback approach is when we fail to send a message. With the callback in place, we can take some action in case of message failure, such as throwing an exception, logging an error, or writing the failed message to some other place for future analysis. However, one important thing to note here is that the callback functions execute in the producer's main thread. We should make sure that the callback is reasonably fast and there are no blocking operations within the callback, as it can slow down the producer. So that was all about the Kafka Producer message sending strategies. If you liked this video, consider sharing it with friends and colleagues. Also, don't forget to subscribe to the channel and press the bell icon. See you later in another video.